So what a logarithm means? Okay, what logarithm means for exponential function? Okay, so uh, as exponent determines if we raise some value to some power, what will be the result? Here, if we take that result as a of log, then which to what power it must be raised to obtain n. Okay, why we need logarithm? Okay, okay, so we need logarithm to find x. Okay, here for example 2 to the power x is equal to 8. So we can guess here we guess 2 to the power 3 is equal to 8. This implies x equal to 3. So it is easy to find x in this case, but for 2 to the power x equal to 10, what is x? Okay, so then we need logarithm. So when apply logarithm, this 2 to the power x equal to 10 will convert to log 10 raised to equal to x. Okay, so x equal to log 10 log 10 raised to. Okay, so we can find this. Okay, so logarithm, why we need logarithm? So we need logarithm in exponential equation when we have a example like mathematics solving linear equation exponential power. So we need to compress larger scales like earthquake, sound intensity. Okay, so we will convert in this logarithm into logarithmic scale. So they are defined in logarithmic scale. So we need the logarithm solving calculus problem like a differential equation. We need logarithm in statistics and machine learning too. Very vast field. This statistics and machine learning is very vast thing. So there too many application of logarithm is there. Okay. Let's talk about duality. Let's talk about duality. Okay. So there is two side of duality, positive side and negative side. So here you can see uh, the a raised to the power log n base a equal to n. So the base and base cancels it. Here also uh, this a and a cancels log and the value will be n. So if you have 3 log power log 3 base 3 5, so that it will be equal to 5, or this is the opposite. There is exponential thing. Here we have log exponent in log. Okay, so this a and a cancels and the value will be x. Okay, so log base 3, 3 to the power 5. So this will be, this cancels and it will be equal to 5. Okay. Uh, then we have transformation power. Transformation power, ability allows us to transform multiplicative relation into additive ones, like when you have a to the power x and y. Okay, so equal to n. Okay, um, we have sorry, log sa n into n is equal to log base a n. Okay, plus log n base n. Okay, so this multiplication converted into addition. Then we have comparison scales, like when exponential term put log there, so then well it will compressed. Okay, and the application is in calculus. Vast application in calculus. Now we discuss negative side of logarithm. So logarithm domain is restricted. Um, n is should be always positive, and a should be greater than 0. A cannot be equal to 1. Okay, so there is a domain restriction, then base restriction. Why a cannot be equal to 1? Because any 1 to the power any value is equal to 1 always. So logarithm would not be unique in that case, so we do not take a equal to 1. And if a is less than 0, the exponential function is not well defined for all real exponent. Okay, so that's why we only take a greater than 0. Uh, if a positive number is to the negative exponent, the value will be always positive. Okay, so if a 3 is raised to power minus 2, then the result will be always greater than 0. Okay, and that n cannot be equal to 0, logarithm not defined for 0. Okay, like log 0 base any base is not defined. There is no near, like for there is no real number x such that a to the power x equal to 0. Okay, if any number 0 to the power any number, that is not defined actually. Okay, no logarithm of negative numbers. Okay, so n, if n is less than 0, then logarithm is not defined. A to the power x is greater than 0 for all x when a is greater than 0. This is fundamental. Okay, if a is greater than 0, a to the power x is always greater than 0. Always. Okay, but a less than 0 is not defined. Logarithm is not defined for a less than 0. Minus n less than 0. Okay, not defined. Let's walk through some examples to understand the positive and negative side of logarithm and exponent. Okay, here example 1. Okay, argument is positive, so log will be positive. Okay, both argument and result are positive. 3 and 4, 3 raised to power 4 is 81, and log of 81 with base 3 is equal to 4. Okay, positive argument 8, 1 by 8. 1 by 8 is greater than 0, that is positive. The value of log is negative. 2 to the power minus 3 is equal to 1 by 8. So log negative. So result can be negative. Okay, then log value of log can be negative. Okay, the argument is positive, but the logarithm is negative. Okay, now example 3. We have positive argument uh, and positive argument which is equal to 1. So this value will come when we have a base has to any power, any base raised to power 0 is equal to 1. So log of 1 with any base is equal to 0. The argument is positive and the logarithm is 0 in this case. Okay? Now negative argument. So negative argument is not allowed. N less than 0 is not allowed. It is not defined. Okay, so we cannot find log of minus it with any base. Okay, so log of any negative number with any base, any positive base, we cannot find. Okay, it is not defined. Now example 4 we see um, argument is 0. So argument cannot be 0. Cannot be 0 also. Okay, so log 0 with any base like 7 or 5 or 2 or 10 is not defined. So we cannot find log for 0. Okay. So there is summary for log positive and negative log. Okay. So we have first condition A is greater than 1 and n is greater than 1. So in that case log is positive. When n is less than 1 and greater than 0, the log is negative. And n is greater than 1, but the base is less than 1 and greater than 0, then log is negative. When both n and a is less than, when both n and base a is less than 1 and greater than 0, in that case log is positive. Okay, and when n is equal to 1, for any valid base, the value is always 0. Okay, so this is the final conclusion. Okay, exponent and logarithm are inverse operation. Exponent with in exponent we multiply the same base many times to get a value. In logarithm we need to find the power to which the base must has to rest to get the value. Okay, so n must be positive, otherwise it is not defined. Okay, understanding this duality principle is important to solve any logarithm problem and any hard problem for JEE exam. Okay, thank you.